Hello my dear students, I am Priya Patil, lecturer in Information Technology Department of Government Polytechnic, Yavatmal. In this session, we will learn the comparison between IPv4 and IPv6 header format. So, after this session, you will be able to explain the comparison between IPv4 and IPv6 header format. This is the basic structure of both IPv4 header and IPv6 header. Here I have used color code so that it will be better for you to understand the availability of the particular field and what is the comparison between that fields. Pink color is used to indicate the fields which are used in IPv4 header format and in also IPv6 header format. Green color field is used to indicate the fields which are available only in IPv4 but not in IPv6. Yellow color is used to indicate the fields which are available in IPv4 and the similar fields are available in IPv6 but the name and the position of that fields in IPv6 is changed. And the blue color is used in only the IPv6 header format and it is used to indicate the field which is new in IPv6 which is not present in IPv4. One by one, we will learn each and every header comparison. Here the pink color again used to indicate the fields which are available both in IPv4 also and IPv6 also. The first field is version number available in IPv4. It is used to indicate the version number of the internet protocol. The name itself indicates that it is internet protocol version number 4. So that in IPv4, this field contains the value 4. In case of IPv6, this field contains the value 6, that is version number 6. Again, source address and destination address both are available in IPv4 also and in IPv6 also. But the difference is that in case of IPv4, it is having the size of 32-bit. And in case of IPv6, source address and destination address both are having the size of 128-bit, means the address space increases in case of IPv6. Next is type of service field. Here, this slide indicates the fields which are used in IPv4 and also in IPv6, but the name and position of that fields are changed. Let us see the type of service field which is equivalent to the traffic class field of the IPv6. It means that it is used to indicate the type of service provided by that packet or the priority of that particular packet. Total length field. Total length field, this field is available in IPv4 and this field is equivalent to the payload length field of the IPv6 header. But the difference is that in case of IPv4, we are using the total length. It means the length of the total packet, means the length of header format plus data in case of IPv4. But in case of IPv6, we are using the payload length. It means length of payload, length of data field and not the header field. It means the length of header is not included in the payload length field of the IPv6 header. Next, same time to live field is equivalent to the hope limit field of the IPv6. These fields are used to indicate the lifetime of that packet. After the completion of that particular lifetime, that packet will get discarded. Next is protocol field. Again, it is equivalent to the next header field of the IPv6 header. Protocol, in case of IPv4, it is used to indicate the protocol which we are going to use in the data field. In case of IPv6, we are using the next header field, equivalent to that protocol field. This next header field contains one of the two values. It may use to indicate the protocol which we are going to use in data field, or it may use to indicate the extension header which is followed by this base header. Okay. Next is the fields which are not kept in IPv6. It means that it is used to indicate the fields which are used in only IPv4 packet format, but the fields which are not used in IPv6 packet format, header format. See here, it is indicated by the faint green color. It is used in IPv4 header, but this color you will not see in the IPv6 header. In IPv4, we are using the internet header length. It is used to indicate the length of the header format. Again, identification, flag and fragment offset. These are the fields related to the fragmentation process which are directly included in the IPv4 header. But these fields are not included in the IPv6 header because the separate extension header called the fragmentation header, extension header, we are going to use in the IPv6 header. So that if we want to perform the fragmentation process, then we have to use the fragmentation extension header in case of IPv6 header. But in case of IPv4, the fields related to the fragmentation process, they are directly included in the header format. Next is a header checksum field. Again, this field is only included in the IPv4. It is used to perform the checksum, that is to check that if there is any data alteration when it is transferred from source to destination, and this checksum is only applied on the header in case of the IPv4 header format. But in case of IPv6, such a checksum field is not included. Next one is again option and padding field. These fields are only available in the IPv4 which are removed again from the IPv6 header format. Option field is used to indicate the type of the option, that is a routing type, whether you are using the loose routing, whether you are using the strict routing. I have already explained all this concept in a previous session. These options are included in this option field. And the padding field is followed by this option field. It is used to make this field up to the 32-bit. In case of IPv6, the option field and padding field both are removed because if you want to specify the particular type of the routing, strict routing, source routing, or any type of the particular routing information, so in that case we have to use the extension header which are available in the IPv6 header format. For example, hop by hop option header, destination option header, extension header. These header formats or headers are available in the IPv6 header format, so we cannot require to include the option and padding in case of IPv6 header. Next is that the new field in the IPv6 which is included in the IPv6 only and not available in the IPv4 is the flow label field, and this field is used by the source and it is used to specify that the spatial handling is required by the that packet, and this field is used by the router, and router can provide the spatial type of the handling to that packet depending on the value of this field. Again, this field is very important in case of the real-time services. But this such a type of the field, flow label, that is to provide the spatial handling to that packet to indicate to the router, such a type of the field is not available in case of the IPv4 header. Now see here, suppose we consider that we are using the IPv4 Internet Protocol version number 4. So in that case, if the computer number A want to send the data packet to the computer B, so in that case, if we are using the IPv4, that packet is visited by each and every intermediate node and each and every intermediate router. So when it is forwarded to the particular destination to the B, it means that it is processed by each and every intermediate router indicated by the blue color and each and every node indicated by the orange color. But in case of IPv6, if we are using the Internet Protocol version number 6, then it depends upon if we are using the if we are using the hop by hop extension header or not. In case of hop by hop extension header, that IPv6 packet is visited by the each and every node and each and every router exactly same as IPv4. But if we are not using the hop by hop extension header, so in that case, that packet is not visited by each and every node. It is visited by the main router only, and it is forwarded directly to that intended destination. So in case of IPv6, if we are not using hop by hop extension header, so in that case, that packet is not visited by each and every intermediate node. Now we will see some of the comparison points between IPv4 and IPv6. IPv4 header is having the size of 20 to 60 byte. It is vary between 20 to 60 byte. But in case of IPv6, this header is having the fixed size, that is 40 byte. In case of IPv4, we are using the 32-bit address length. It means that the source and destination both are having the address length of 32-bit. But in case of IPv6, this source address and destination address both are having the size of 128-bit. Because of this, the address space increases and more computers you are able to connect in that network. In case of IPv4, binary bits are separated by the dots. It means that if we are using the address representation, so that in that case you have to use the dots. These dots are used to separate the binary bit. But in case of IPv6, the colon is used to separate the binary bits. In IPv4, address representation is in decimal format, and in IPv6 you have to use the hexadecimal format. It means you have to use the 0 to 9 and again continue up to the F, 0 to F. Sorry, E. IPv4 header format contains the 12 fields in the header format, and in case of IPv6, header fields are 8. IPv4 support the broadcasting, but in case of IPv6, it cannot support the broadcasting. It supports the unicasting, that is one-to-one communication, one sender, one receiver, or multicasting, that is one sender, many receivers. But if you have to use the broadcasting, then you have to use the multicasting, that is one computer, one sender and many receiver. And so in that case, you have to use the broadcasting, then multiple receivers as consider as the all receiver. In case of IPv4, fragmentation is performed by the sender and forwarding routers. But in case of IPv6, fragmentation performed only by the sender. In case of IPv4, we have included the identification, flag, fragment offset. These fields are already available in the IPv4 header format, and these fields are related to the fragmentation process, so that any intermediate node or any intermediate router which receives the IPv4 packet can perform the fragmentation process, because this field, this information itself contained in the header format. But in case of IPv6, fragmentation is performed only by the sender. So, if the fragmentation process is required to perform, the fields related to the fragmentation process are included in the fragmentation extension header of IPv6 format. Encryption and authentication facility is not provided in the IPv4. But in case of IPv6, encryption and authentication facility is provided by using the extension header again. Encryption extension header is used in IPv6 format. Again, authentication payload length header extension header is again used in IPv6 format to provide this facility. It means the separate extension headers are available in case of IPv6 to provide the authentication and encryption. Encryptions are provided in case of the IPv6. IPv4 cannot support auto configuration, but IPv6 can support the auto configuration. Next is that IPv4 cannot support the real-time applications, but IPv4 can support the real-time application. We can say that the IPv6 support real-time application because in case of IPv6 we are using the field flow label, which is used to support the real-time application, that is to provide the spatial handling to that packet by the routers, intermediate routers. But in case of IPv4, we are not using such a field called flow label. Throughput and delay is more in case of the IPv4 and is less in case of IPv6. I have already shown you that in case of IPv4, the packet is visited by each and every intermediate node and each and every intermediate router, so that the delay will get more in case of IPv4. But in case of IPv6, the delay is less because the packet is not visited by each and every node and each and every router if you are not using the hope by hope option extension header. That's the beneficial. So all this about the comparison between IPv4 and IPv6 packet format. After this session, if you have any questions or any doubts regarding this topic, then you can feel free to contact me by using my Gmail ID, that is patil.priya2289@gmail.com. Thank you.